You're going to measure the distance from the center of this rod to the center of this axle. So you're going to have to do some estimating there. I'm going to say your uncertainty is plus or minus at least a millimeter. At least. Okay? So plus or minus 0.001 meters. Now, how are we going to determine what force the spring is exerting when it's in this configuration? Well, you should see another piece of string. Is it still recording? Yeah, oh yeah, I see it. How much do I have? Does it say?
You got about 12 minutes.
Oh, I have 12 minutes, okay. So there's a paper clip that goes through, there's like a little peg with a hole in it on the other side of the spring. I mean the mass from the spring. And you thread it through there. Then you're going to thread that over this pulley. And another thing I tell you in the pre-lecture is that the pulley is only going to change the direction of the force. It doesn't change the size of the force. These mass hangers are already 50 grams. And what you're going to do is use the weight of the mass to stretch the spring out to that given radius. And this will change with each row of the data table. So I've got it at the biggest radius right now. So there's 150, there's 250. It needs to have room to hang down. Let's see. I don't think it's going to be 350, but it might be. Okay, there's 250, so there's 350. Oh my word. There's 400. Should have brought more masses up here. Okay. I'm going to put a 500 on here. That'll be too much. Oh, it's not even enough. All the springs have a little bit different stiffness. That is a pretty stiff spring. 650, 750. I'm almost there. 850. We'll call that there, but probably. Oh wait, let me put one more on. Yeah, that looks good. Doesn't that look pretty good? Pretty lined up. Okay, so the radius is the distance between this pole and that rod. And then you'll see it says mass in that next column. That's the mass of whatever you had to hang on here to get this to line up over that post. Okay? So I don't know what I said, but I was counting them as I did them. So for this trial, it would have been 550, 650, 750, 850, 900. Don't forget the mass hanger is already 50. But when I did this before, I had a much less stiff spring, and I was able to do it with 250 grams. So, okay, now, how do you change grams to kilograms? Divide by 1,000. So move the decimal 3 places to the left. So don't put grams here, you want kilograms. So mass should be in kilograms. And then F, I'm going to put a subscript net on it, and I'm not sure I have that in the data table. The force is the net force, because now take this paper clip off. That's the force this spring exerts when you have it stretched this much. Okay? So that should be in newtons. And the way you're going to get that is by multiplying this mass times 9.8, 9.81, whatever way you want to play it. That's the gravitational field strength. 9.81 newtons per kilogram. Now, there are two masses in this experiment. You will also need to find, at some point, the mass of this thing and the mass of the spring, the mass of the sinker, or do we call, what do we call it?
It says in the book it's 50, or it's
What? No. What?
it says it's 50 grams and
No. Where are you reading that?
oh, never mind, that was
The hanging mass.
My bad.
This is like the going around in a circle mass. So here's the deal. This going around in the circle mass, this heavy mass, is experiencing a centripetal acceleration. So what you're going to do is make a graph. Can you come over here? And I certainly hope this is what I tell you to do. And I'm a little worried I tell you the other way in the book. You're going to make a graph of net force versus acceleration, just like you did last week. And, I mean, hopefully it's a straight line again. So you're going to do a best fit line. Okay, now the slope of that best fit line ought to be the mass of the sinker, okay? Not the hanging mass. So you got to be sure you keep that straight. Mass of the sinker. And the mass of this sinker is going to have to be determined on the double pan balance, because that digital scale that's near the printer doesn't go up high enough. Let me give you a ballpark for that. It's like 450 grams. Okay, so this is almost a half a kilogram, and it'll give you an error message if you try it on the digital scale. Okay, so I'm going to want a percent difference. What do I want the percent difference to be between? The mass of the sinker, well, you adjust it to take into account the mass of the spring. The directions are in there. You're going to compare that adjusted mass to the slope of your graph. So that's what your percent difference is going to be between those two things. Absolute value of the difference between sinker mass adjusted and the slope divided by the average of those two times 100 with a percent sign in it. Okay? Adjusted sinker mass plus the slope divided by 2. Okay, that's it in a nutshell. Questions? Okay, now, can you think of anything that's confusing you that might be confusing someone who's not here to ask me a question?
So just do like 5 trials at different radii?
Different radii. So I think I tell you to do, like, split the distance from the closest to the farthest up into five different radii.